Okay, so we are looking at the relations and the functions. Okay, so our focus is on relation and functions. So we use to teach this, we use a tutorial sheet that was produced in 2021 or in 2022 last year. On relations and functions. So the most important questions that are asked, or the type that you expect when you're doing relations and functions, have been listed down in this. So we'll first begin with relations, and we'll look at the Cartesian product of two sets. That will be the first thing. So as I'll be solving, I'll be explaining where need is required. So they are saying the Cartesian product of two sets is defined by, so this is the definition actually of the Cartesian product. If you do A plus B, you get A comma B, given that A is coming from the set A and B is coming from the set B. So what do they mean? What they just simply mean is, if you have sets like A, you have the element there, then you do close with B, and this B has the element, and this B has the element B, like that. Then the Cartesian product is defined as A comma B. That's the meaning of that. So each corresponding element, you'll see when we answer the question that has been given, will be given as that. So let's answer the first question. Okay, so there are two definitions. For B plus A, it's B comma A. For A plus B, it's A comma B. So now the question is, let the universal set, which is 1, 2, 3, 4, 5, A be 1, 3, 5, and B is hex, where hex is a prime number. So the first thing that you need to do is, first of all, list these two sets, A and B. Okay, so go to our board. The first thing that we've been given that A is 1. No, sorry. I think A is 1, 3, 1, 3, 5. And then they given us to say B is a prime number. Now, for us to list prime numbers, we need to know what our universal is. So we've been given to say the universal only contains 1, 2, 3, 4, 5. So this being the universal, B can only come from this set, which is the universal. So which ones are prime numbers from this set? So we find that the prime numbers is 2, 3, and 5. Okay, so 2, 3, and 5. Let's remind ourselves what prime numbers are. It's numbers that are only divisible by 1 and itself. In other words, they only have two factors, which is 1 and itself. So 2 is the only even number that is prime. The rest are odd numbers that are prime. So 3 and 5. So these are the two sets that you have, A and B. Now let's look at the question. What exactly do they want? What they want is find the elements of A complement plus B complement. So for you to get this, for you to get A complement, so what they want is A complement plus B complement. So for you to get this, you first need to come up with A complement and B complement. So from what we have, of course, everything should be compared to the universal set, not to B, not to A. So when you come to A, compare it with the universal set, complement its elements that are not in A, but they are in the universal set. So 1 is in A, 2 is not in A, so it's in its complement set. 3 is in A, 4 is in the complement sets, and 5 is there. So this is A complement, elements that are not in A, but they are in the universal set. Then you also come up with the set B complement, elements that are in the universal, but not in B. So you look at 2, it's there. So we have 1, 2 is there, 3 is there, 4 is not there. So it means B complement has 1, 4. So now the way it is with the Cartesian, according to the definition, let's remind ourselves how they've defined it to say, if you have A cross B, it is given as A cross B, A cross B is given as A comma B. And this is coming from A, this is coming from B. Remind ourselves, this is how it is. So the way it is, when you do, so A complement is 2, 4, cross 1, 4. So when you do the cross, what you are going to have is 2 cross 1, so it will be 2, 1. You have the pair that is in form of A, B. Then this same 2 will do a cross with 4. So you are going to have 2 cross 2, 4. Then 2 is done. Then you go to 4, so you are going to have 4, 1. Then finally 4 will cross with 4. So you are going to have 4, 4. And that is the set of A complement cross B complement. So that is what is the required end result in form of a set. Okay. So that is how you go about question 1, given what we've been given. Okay. So for more questions, you can simply do the needful. So let's go to the second question. The second question is, let A be equal to 4, 6, 8, 10, B 2, 3, 4, 5. Okay, so let's have our sets down ready for us to answer the question. So we have A, they are saying it's a set 4, 6, 8, 10. Then they are saying B is, what is our B? Let's go look at what we have in our B. So this is 4, 6, 8, 10, 2, 3, 4, 5. 2, 3, 4, 5. Our B is 2, 3, 4, 5. Okay, so that is our B. Then let's find out what exactly they want. So they are saying hala be a relation defined on A to B, where hala is, so the same thing that was given. So if we can see, hala is defined as A, B, where A is a member of that, and that is that A is a multiple of B. So one thing that we have been given is A is a member of B. A is a member of A, and B is a member of B, and A is a multiple of B. So multiples of B, it is the numbers that numbers in B can go in. So we've been told A should be a multiple of B. So What does that mean? For example, A, if I pick my A to be 4, 4 will pair with every number that can go into 4. So the first one will be 4, 2. 2 can go in 4. Then we can also have 4, 4, because 4 is a multiple of that. Then and so on and so on. So let's look at what we have. Very clear, very clever. So we can only pair multiples. So we are going to come up with HARA. So they are telling us to say, in roster form, come up with HARA and its inverse. So it's simple. If we come up with HARA, then its inverse is a trivial solution. A trivial solution. It's very simple then. So conditions are that HARA should have A, B, that's the condition, where A is a member of A and B being a member of B, but multiple of what? It's a multiple of B. A is a multiple of B. So A is a multiple of B. That is that. So we'll start. One thing that we just have to realize is that A should be a multiple of B. So we are going to come up with HARA. So we'll start with 4, 4, 2. Then is there another number that is in B that can go into 4? Then we can have 4, 4. So we are done with 4, no other multiple. Then we go to 6. So 6, 2 can go in 6. And then 6, 3 can go in 6. So that's it, 6. Then we can go to 8. 8 has 2, 8 and 4. Then finally we can go to 10. 10 and 2. The other number that can go in 10 coming from the set B is 10 and 5. So that is our HARA. So that is in roster 4. So now take note, the condition is that A is supposed to be a multiple of B. So this is in form of A, B. What we mean when we say multiple of B, they are saying if B is multiplied with any integer or some integer, it will be able to give 4. In other words, B is a factor of A, since A is a multiple of B. So numbers that can go in that's how we are not just guessing these things, but it was as instructed according to the definition. So having done that, if this is our HARA, then its inverse, no need for you to even think, just swap. Just swap. 4, 2 becomes 2, 4. That's the inverse. 4, 4, the 4 swaps, it will be 4, 4 again. Then 6, 2, that will be 2, 6. Then that will be 3, 6. Then that will be 2, 8. Then that will be 4, 8. And that will be 2, 10. And that will be 5, 10. And finally, that's the inverse of HARA. Okay. So being here happy, so that is what is required. Now let's look at the second domain. Domain is the values of x if you are to plot this in form of, so the domain are the values of x, and we all know that coordinates are written in form of x comma y. So now what they want is the domain of Hara. Domain of Hara. So domain of Hara are the x coordinates in these pairs. So these are paired as x comma y, x comma y. But we are only interested in the x coordinates because we are looking at the domain. Domain are x coordinates, range is y coordinates. So the domain of Hara is, so we'll start here. We have 4. We have 6. We also have 8. We are not repeating. So we have 8. We have 10. In other words, the domain is the set. Then C is just simply the range of Hara. So the range of Hara have the y coordinates. So, the range of Hara is the y coordinates. So it is this 2, 4, 3, 2, 4, 2, 5. So it is, the range is from 2, 3, 4, and 5. In other words, the set B. So that is how you find question 2. That's how you solve question 2. Okay. So those are the relations that we have. Then we will look at the third question. Let R be a relation on natural numbers defined by x. We all know, first of all, we all know that natural numbers are counting numbers. Natural numbers are counting numbers. Now, counting numbers, it's 1, 2, 3, 4, 5, 6. In other words, they are whole numbers. Those are natural numbers. But then there is a condition here to say this R is x comma x squared. So you just don't get any out. Then they tell you that x is a prime number less than 15. So the first thing is, let's come up with a set of prime numbers less than 15. So I said 2, 3, 5, 7, 11, and 13. These are prime numbers less than 13. These are prime numbers. Then they tell you to say x is a prime number less than 15. So these are the prime numbers. Then they tell you to say the R is that. So what you expect R to be is this. Simple as that. So this one will just do. So this one I'm doing is part A. I'll just do it from the question paper right here because it's straightforward. So what we'll have is, we'll get 2 as the first entry because it's x. So our x is 2, comma. Then the same 2 is squared. So it will be 2 squared, and that gives us 4. Then you go to the next one. You go to 3, comma. You square 3, you get 9. Then you go to 5. You square 5, you get 25. You go to 7. You square that, you get 49. You go to 11. You square that, you get 121. And finally, you go to 13. You square that, you get 169, if I'm not mistaken. I just confirm. So this is hara. And the inverse in roster form, of course, you guys are geniuses up to this stage. So it means the inverse will be the opposite of what we've just done, because I already explained how to get the inverse. It's just swap these coordinates. So the inverse will be 4, 2. Just the opposite. The x squared comes this side, the x goes the other side. Then you have 9, 3. Then you have 25, 5. And you also have 49, 7. And you also have 121, 11. And finally, you have 169, 13. Okay. Then that is it. And that's the hara inverse. So that's how you do hara inverse. Okay. Then the domain, of course, I already talked about how to get the domain of, so now this time they want the domain of hara inverse, the domain of hara inverse. So the domain of hara inverse will just be the x coordinate from hara inverse, which is 4, 9, 25, 49, 121, and 169. So that is domain of hara inverse. Then the range is now the y-axis. So the range of hara inverse, it will be 2, 3, 5, 7, 11, and 13. And finally, the codomain is the range. So the codomain of hara, which is the range of hara, is just, so the other name for codomain of hara is range. That is the codomain. So the range of hara is the x or the y coordinate, which is 4, 9, which is the same as the domain of hara inverse. Because this now is the hara, so it's 4, 9, 25, 49, 121, and 169, like that. So that's what we have. Okay. So that is how you do question 3. That's how question 3 is supposed to be solved. Okay. So then we progress. That was question 3 in a very clear, noble manner. We proceed to question 4. So question 4 is just a matter of state with a justification whether each of the following defines a function or not. So one needs to know what a function is. What's important is know what a function is. So one thing with the diagrams like this, one thing that you should know is a function, if you have A, B, C, then here you can have A, B, D. When you do that, you can have that and that. This is very okay. So each element from the domain, X should only, so in other words, one element should only be able to, okay, no, I think, sorry, not the way I've written it. Okay, not the way I've written it. It's supposed to be like this. Okay. Okay, so we can have something like this. Then we can have maybe let's say G. So only one halo should come from one element in the domain. But in the range, it doesn't matter how many from the range goes to the same element. So you can have A, comma, B like that. And we can also have the way we have B, comma, B. But what we should not have is this. A, then we have elements here. Let's say 2, 3, 4. We having two halos coming from the same element from the domain. This is not a function. This is not a function as long as there are two halos coming from the same. So we can't have A, comma 2, and we can't have A, comma 3. This is not a function. So a function should only one element in the domain corresponding to one or more that. So in other words, we are saying a function can only be a mapping that is one, a mapping that is 1 to 1, a mapping that is 1 to 1, or 1 to many. That is a function, definition of a function. Each element in the range, in the domain, can only map to exactly one element or one element to many. But we cannot have many to one or many to many. So many to many does not exist. So this is not a function. So we are going to identify which elements only has one element from the domain, and those are the ones that will be identified as functions. So it's just a matter of identifying. So we'll be looking at the hex coordinate. Our interest will not be on the range, but on the domain. So we'll be stating the domain. So we'll begin with the first one. So if we are to state the domain of the first one, which is this one, the domain of this guy is 4. We have 4 here. Then we have 3. And then we have 4 again. So this is not a function, not a function, not. Then we go here because why is it not a function? 4 has appeared twice. It means 4 is mapping to 2 different numbers. 4 is mapping to 3 and the same 4 is mapping to 7. So this is not a function. Then we come here, the domain, we list the domain. We have 2, we have 3, we have 1. And unfortunately, the 2 appears again for the second time. So which kills everything. So even this one is not a function. Even that one is not a function. Okay, then let's go to C. So automatically from C, you can see that there are 2 arrows coming from here. It's mapping 1 and also Z. So even this C is not a function. Then we come here, so this is a function. Then using the line test, we said a function, when you draw a vertical line test, only cuts at one value. So if you, the function at only 1 point. So if you are to draw the line test, you find that you'll be able to get, if you draw, this is the hex. So it means if you take your hex to be, let's say -2, you find this -2 is giving you this y value, and it's also giving you this y value. So you do the vertical line test, you find that it's giving 2 y coordinates, the same value of x. You find that maybe it's giving you, this is +4, and here it gives you -4. So this is not a function, not a function. Then when you draw this one, you do the vertical line test, it's only cutting the function at only 1 point. So this is a function. So this is a function. So we only have two functions, this one and this one. The rest are not functions because I've explained, oh, actually, this is a function because this is the same point. It's just a repetition of the point. So this is the function. Yes, this is a function. I didn't take note of the coordinate that is on the other end. This is a function. So this is a function. Because this is just a repetition of the point. This point and that point is the same. So this point has just been repeated. So we can eliminate one. Then when we eliminate one, we can take note of what we have now as our domain. It's exactly the same 2, 1, 2, 1. So it's not repeating. We have 2, 3, 1, and 4. So it means there are no the numbers that are repeating in the domain. So this is a function. So this is a function. You see where the confusion was? It's this because I didn't take note. I was just looking at the x values and I noted that there is a 2 there and there is a 2. I didn't take note of the y coordinate. It is the same. So it's just the point and it's on the same point. It's 2, 1. So this is a function. This is a function. That's a function. These are not functions. The way they are aligned is the way they are. So those are not functions, and those three are functions. Okay, so what's important is you should know that what I've explained. Okay, let's proceed and go to the next question. Let's proceed and go to the next question. So now what we have on question 5, these are called piecewise functions. These are called piecewise functions. Now, with the piecewise functions, it is good to take note of what the domain is about. So we have the domain. So what has been given here is the domain. So this function is on 3 parts, like the name itself, piecewise function. So we have 3. The first one is the line y is equals to 1. But they are saying this line y is equals to 1. So this is the one. Is only valid for x greater than 0. Then we have the line y is equals to 0. We have the line y is equals to 0. And this is only valid from -1 to 0. That's the domain. Then we have y is equals to -1. And this is valid from x -1 or less. So x is less or equal to -1. So now they are saying, let's put up this, a drawing for this guy. So the given function is like this. Write it as the way it has been given. So we have 1, 0, and -1. So we are saying x is greater than 1. Then here, okay, is it greater than 1 or 0? X is greater than 0. X is greater than 0. So here, x is greater than 0. Then we have -1 less than x less or equal to 0. Then the third one is x is less than or equal to -1. So sketching this will not be a problem. All you need is just sketch the. So you have this, it's a sketch. Don't mind my drawings. What's important is take note of the numbers. So this is the y, this is the x coordinate. So the first one is the line y is equals to 1. Like I said, this is y is equals to 1. So it will pass through 1. So let's say our 1 is here. This is where our y is 1. And they are saying this graph starts from 0. So you're going to have from 0. So since there is no equal to, just going to be an open. There, it's open. Then it goes to, so it's a straight line passing through 1. So it goes this side. So it goes greater than, so it goes, we don't even know where, because it's open, it goes up to infinity. So it's a straight line there. Okay, let me just use maybe a different ink, different from the, so it will be from here going this side, and it will be open. And this is y is equals to 1, the first one. X greater than 0. So greater than 0, we know it's going this side, positive. Then we come here between 0 and -1, it is 0. So starting from here, but take note, there is equal to on 0. So it will be a shaded point here. It will be a shaded point there. And the line is y is equals to 0. So y is equals to 0, it's the x axis. So it's a line that will move from there to there. So the thing, so this will be the line from there to there, and it goes all the way up to -1. So this is where -1 is, and there -1, there is no, so it will be open. Then x is -1. So you have your y is -1, you have your -1 there. So starting from there, but then they are saying equal to, so it will be a closed, it will be closed there. So it will be closed there. And it goes less than, so it will go this side. Okay, so you are doing it from wherever you are doing it, it should be all the way from negative infinity up to here. So it will be a straight line through that. So it would go through to go through this. So this is the piecewise function. So the red line, that's our graph. And here it should open. So this is the line y is equals to 0, the middle part. The y is equals to 0, then there it's y is equals to -1. That's the y equals -1. Like that. So this is how our graph looks like. Then below there, so this is just the first one. Then they have said for each of the graphs, we need to find f of -0. But I won't find everything for you guys. I'll just do maybe the first one, -0.25. So you just say -0.25. Is it going to be on this range, that range, or that range? So -0.25 is on this range. So the answer for this one is 0, this. Then for 0, where is 0 equal to? It's on this same one. So for 0, it's also that. Then for 7, f of 7, 7, it's the one that we are saying greater than 0. So x is greater than 0, 7 is greater than 0. So it is 1. So for this one, it's 1. I'm just doing on this first one. I have not touched the second one. Then for D, -20 is less than -1. So for -20, it will be -1 because x is less than -20. So that -20 here is less than -1, this -1. So it is -1. Then G is 0. Oh, that was just F. So F ends there. Of course, that's just F. Then for G, we can have the graph there. And we'll do well, of course. So we are going to sketch these graphs, okay? So you need to know, so the first one, the graph that will be there is y is equals to 2 in the range for x less than 0. Then the next one is y is equals to x squared plus 1. This is a quadratic equation. Then you have y is equals to -1. So we have y is equals to 2, but of course with the domain from 0 to 4 on the middle one, here less than that. So let's go to our graph. Let's go to our table and come up with. So let's have, first of all, what is our function? G of x. So our g of x, is given by, so we have 2, then we have x squared plus 1, then we have what else? We have -1. We have -1. Then we've been given to say this is for x less than 0. X less than 0. Then the next one, 0. X is between 0 and 4. Of course, x is between less or equal to 0 and 4. Automatically, x is greater than 4. Just for confirmation, x is greater than 4. So that's what we have. So the thing is, you first sketch. So y is equals to 2. So when you have that, yes, that's how we do things. So we are saying x is less than 0. We know y is equals to 2. Let's put our y is here. And then it's starting from there. So it starts from 2, from 0. But it's going to be open because there is no equal to there. Then 2. So it's less than, so it will be all the way on the left. We don't even know where it will end. A straight line. Okay, let's use a different ink. Okay, the black is, okay. Do we have one way to move? Okay, just that color. I think we can maintain the red color. So let's have our line. We don't know where it's coming from. It's coming from -infinity because it's open there. X is less or equal to 0. So it comes up to 0. It's going to be a open, don't shade. And then this is a quadratic. We know a quadratic is either of this form or that form. So find out, what you do is just get the 0 and set there. When you put 0 there, it will start at 1. So it will be at 1. And remember, at 1 there, it is at 1 there. So it should be like that. Then when you put 4, x, when you put 4 there, it will be 4 squared, and that will be 16 plus 1, 17. So it goes all the way like that. It's a curve. So it goes all the way to here. And of course, it will be crossed because there is equal to. But take note, it's not a straight line. This is a curve. This is a curve. So here it should be 4. And here on top should be 17. Because when you insert 4 there, it goes 4 squared. That will be 16 plus 1, 17. So it should be 17. And it will look like that. Then -1. So -1 somewhere here. So you say y is -1. And it starts from 4. So it starts from 4 there on -1. And it's open, saying greater than 4. So it's greater than, it goes all the way this side. And we don't know where it's ending. So this is our y is equals to -1. Then this is our graph. Our y is equals to x squared plus 1. Then this is our y is equals to 2. So that's our function will look like. So that's how our function will look. Okay, so having done this piecewise function, the next thing that you do now is answer the questions that follows. So like I told you, Of course, you can even tell from the graph that this is what they want. So let's say, for example, G is equals to 0. When you come to your graph, if you want to find G is equals to 0, you want to find your G is equals to 0 when X is 0. So X is 0 is here. So the function that has X is equals to 0 is that one. So you're going to use this function to find G is equals to 0. So you're going to get that. You put 0 squared plus 1. So it will give you 1. So G0 is 1. So you use that function because when you have your 0 here, it's this one that has 0. Then you go to the next one. You have your G is equals to 4, G4. So you find that your G4, your G of 4 is just simply G of 4, so there is the one. G of 4, that is the 4. The same function, of course, it's giving you 17. No need for you to worry or start solving. You just insert in the same to give you 17. That's G of 4. Then you can also get your G of negative 2. So G of negative 2. So you find that your G of negative 2, what is it going to be? So you say your negative 2 is somewhere here. Let's say your negative 2 is here. The line that is negative 2 is this one. So automatically the answer is 2. Y is 2. And you see X is less than 0. So any number that is less than 0, you can tell that it will give you 2 as your answer. So negative 2 is less than 0. And that's why it's 2, because it will be there and the value of Y is 2. So then you have your next one is G of 7.5. G of 7.5. So you can see clearly from the graph that your G is G of 7.5. G is greater than 4. G is greater than 4. So automatically it should be negative 1. And you can tell if you pick, say 7.5 is somewhere here, you draw a line there. It's cutting this line, and that line is negative 1. So that is how you find those ones. So this is what we call a piecewise function. For today, we end here. Look out for the next the next video on functions. We'll continue solving these questions until we reach the part of graphing. So enjoy the video, go through again, and make sure you click on that button, subscribe. Thank you.